So if you see here, we have t square and t raised to minus half. So t square and t raised to minus half will become t raised to 2 minus half, which is t raised to 4 minus 1 upon 2, which is t cube upon 2. So these two terms, so t square into t raised to minus half can be replaced by t raised to 3 by 2. And if you observe only this part is similar to this part. E raised to minus x, here we have e raised to minus t. X raised to n minus 1, here we have t raised to 3 by 2. Then again we are going to do the same thing what we done here. So here we have t and here we have t raised to minus half. So t into t raised to minus half is nothing but t raised to 1 minus half, which is t raised to half. So these two terms will be converted into t raised to half. Okay. So if you observe this term is also matching with this term. Here we have e raised to minus x, here we have e raised to minus t. Here we have x raised to n minus 1, here we have t raised to half. Similarly, this term is also matching with this term. So now here we have n minus 1. If we compare these two terms, we have n minus 1 equal to this term. Always remember, it is not n, it is n minus 1. So n will be 3 by 2 plus 1, which is 5 by 2. So this part, only this part is nothing but gamma of 5 by 2. Okay, into 1 by 9. And here we have minus 8 by 3 will remain as it is. And here if we compare this to equation, here we have half, and half is nothing but n minus 1, because we have x raised to n minus 1, only x is replaced by t. So n will be half plus 1, which is n is 3 by 2. So this whole term is nothing but gamma of 3 by 2. Plus we have 16 into this term. This term is matching with this term. If we compare these two, we get n minus 1 equal to minus half, and n in our case will be half. So this term is nothing but 16 gamma of half. So again I am going to write this equation. We get I equal to 1 upon 2 root 3 is outside. Then we have 1 by 9 gamma of 5 by 2. So 1 by 9 gamma of 5 by 2. Then we have minus sign 8 by 3 gamma of 3 by 2. Minus 8 by 3 gamma of 3 by 2. Then we have plus 16 gamma of half. Plus 16 gamma of half. So here if you see, here we have the fractions. So here we are going to apply the property of gamma, which is gamma of n equal to gamma of n minus 1 into gamma of n minus 1. And then again we apply gamma. So gamma of n minus 1 is nothing but n minus 2 gamma of n minus 2, and so on. So 1 upon 2 root 3 will remain as it is. Then we have 1 upon 9. What is gamma of 5 by 2? So here n is 5 by 2. So gamma of 5 by 2 is 5 by 2 minus 1, which is 3 by 2. Then we have n minus 2. N minus 2 is 5 by 2 minus 2 will be half. Then we have gamma of n minus 2, so which is half. 3 by 2 into half, and gamma of half is root pi. So this will be 3 upon 4 root pi. You can directly write this like you have to subtract 2 from 5. So 5 minus 2 is 3 will be in the numerator and 2 will remain as it is. Then you have to subtract this. 3 minus 2 is 1 upon 2. When we subtract 1 and 2, we get negative term. When we get negative term, we just write the gamma of the last term, which is gamma of half. Okay, so if you see, these two are similar. So this is the fastest way to write the gamma of fraction, minus 8 by 3. Similarly, here we are going to apply gamma of 3 by 2. So 3 minus 2 is 1, so 1, and in the denominator it will be 2. And since we cannot further subtract because it will become negative, so gamma of this term, which is half, plus 16 gamma of half. We know that gamma of half is nothing but root pi. So we get gamma of half as root pi, and then this 3 1s are 3 and 3 3s are 9. 3 into 2 is 12. So 1 upon 12 root pi minus 8 upon 3 into 2 is 6, and gamma of half is root pi plus 16 gamma of half is root pi. If we take root pi outside, we get root pi upon 2 root 3. After this, here we have 12, so we take the LCM. So we get 1 minus 8 into 2 is 16 plus 16 into 12 is 192 upon 12. So if we solve this, we get root pi upon 2 root 3. This value turns out to be 177 upon 12. So this is our final value of the given problem, and this is how we solve the problem on gamma function. More such problems we will see in our next video, so stay tuned for our future lectures.